Hello guys, welcome to the second session of PRMO solutions for 2019 of the second leg exams. I'm sure you guys have attended the session taken by Shivam sir in which we discussed the first 10 questions. This is a continuation to the same session and let's move on with the first question. Okay, and before I move on with this session, let me inform you that the RMO classes from Vedantu is starting from 2nd of September and you can join the session for a special price at just 500 rupees by clicking the link vdnt.in/RMO. I'll write it over here once. It's vdnt.in/RMO. Okay, so the session will begin at 2nd of September and the entire team of Vedantu is waiting for you guys so that we can repeat the success that we got at pre-RMO in RMO as well. Okay guys, so let's begin with the solutions from question number 11th. Okay, so have a look. The question tells you that you need to find the largest value of a power b such that positive integers a and b greater than 1 satisfy the equation a power b into b power a plus a power b into plus b power a is equal to 5329. So what I am able to see is the term as it is not exactly factorizable. So what I do is I add plus 1. You see, when I add a plus 1, I am able to see that I can factorize the term pretty easily. Let me show you guys. So, I have a power b into b power a plus a power b plus b power a is equal to 5329. So, what I do is I simply add 1 on both sides. So, what do I get? This is simplified as a power b plus 1 into b power a plus 1. I hope you guys are able to see this. And what do we have over here? So we have 5330. So when you break it down, you will see that it is comprising of 2 into 41 into 5 into 13. Okay guys, so all of these are prime numbers, so we can't simplify it any further. So now we need to find two terms. We have to combine two of them or three of them and form a power b plus 1 and b power a plus 1 in such that a power b is highest. So let's try combining a few of them. Okay, so first of all, let me try and combine. Okay, we need biggest power of a power b. So what will I think first? I'll try and combine 41 and 13. So I'll get two terms as 41 into 13 and 5 into 2. So now checking for 41 into 13 will be tough. So what do? I take the second one. So that is 2 into 5 which is equal to 10. Now this will be either a power b plus 1 or b power a plus 1. Okay guys, so what will I get? I'll get a power b is equal to 9. What is this? This will be 3 square. But you can see when I take b power a, I will get 8. So b power a will be 8 and we'll get a 9 over there, which is not equal to 41 into 13. So that's why we need to cut this. So this is a wrong solution. Okay, so next what do? Okay, let me rub this. So taking 41 and 13 together is absolutely wrong. So what do next? Next I can try and take 13 and 5 together. Okay, so 13 and 5 taking together, I get 65 multiplied by 82. Now I'm able to see that this is really good two numbers. Why is that? That's because this is nothing but 3 power 4 plus 1 multiplied by 4 power 3 plus 1. Okay guys, so this will be the biggest possible thing. What else is there? Do you think is there anything else left? Okay, we can try 41 into 5. So instead of checking 41 into 5, what we can check is 2 into 13. So what will be 2 into 13? 2 into 13 will again be 26. This is nothing but 5 square plus 1. And what will be the other term? If this is a power b plus 1, so we have taken 2 and 13 together. So we got 26 and what we got was a power b is equal to 5 square. So b power a plus 1 will be equal to 2 power 5 plus 1. So what is 2 power 5? 2 power 5 is 32. So 32 plus 1 will be 33. And this, my friends, is not equal to 5 into 41. So that's why this answer is wrong as well. So what are we left with? And we need to find the biggest one. Now we can take some other small numbers as well. We can take 2 and 13 together. We have shown that it's not possible. So the only possibility left over here is 82 into 65. wherein a power b is 81 and b power a is 64. Why did we take the bigger one? We have been asked to find the largest value of a power b. So we can take a power b as 64 or we can take a power b as 81. But since 81 is larger, our answer a power b should be equal to 81. Okay guys, so that's why the largest value of a power b will be 81. Okay, let's move on to the next question. Okay guys, here's the next question. So next question is question number 12 and let's read what is given. So n is the number of ways of choosing a subset of 5 distinct numbers from the set 10a plus b, where a goes from 1 to 5 and b goes from 1 to 5. Now what we need to find is the number of different subsets we will be able to get. Okay, so what's this? What are the numbers that we have? Let me just write it down in a simplified manner. So since the 10th place goes from 1 to 5 and the 1st place also goes from 1 to 5. Okay, so we will have numbers from 11, 12 and this will go on till 15. Okay guys, then we'll have 21 and this will go on till 51, and from 51 we'll have 52 and this will go on till 55. So okay guys, so basically we have a total of 25 numbers. Now what are we asked? We need to select 5 distinct numbers. So 5 distinct numbers. So let's see, from this first range, so none of them and should have same units place or the same tens digits place. Okay guys, so what will happen? So one value we'll have to select from the top row. We'll be allowed to select only one, because if we select the second number from this row, the tens place of both numbers will be same. So that's why we are allowed to select only one number from the first row. So what do we have? Okay, we have a 5C1. So what happens now is, regardless of which one of the 5 you select, so one of the ones digits is taken. So when we move on to the 21 series, 21 to 25, one of them will have the same ones digit value as the one from the first series. So that's why we can't take that one. So what will happen? We'll be only able to select 4C1. Similarly, when we go on down, it goes on decreasing. So there will be 3C1, there will be 2C1 and finally there will be a 1C1. Okay guys, so this is nothing but 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay guys, so I hope you guys know the value of 5 into 4 into 3 into 2 into 1. This is nothing but 120. So that's why there are 120 ways of selecting a number from the given set, for selecting a subset of 5 different numbers. Okay, so now what's the question? Have a look, the question doesn't end here. What it says is, what's the remainder when n is divided by 73? So what do we have to do? We need to divide this 120 by 73. So it's sure that it will divide only once. So what will be the remainder? The remainder will be nothing but 120 minus 73, that is 47. So 47 is the answer for the 12th question. Okay guys, alright, let's move on to the next question. Alright, for now what I am telling you guys is, don't even look at these values. We don't have to look at them. What are we given? We have been given that it consists of sums of distinct powers of 7, that is 7 power 0, 7 power 1, 7 power 0 plus 1 and then 7 square. Are you guys able to see? There's an increasing trend. What does that look like? It looks like 7 power 0. Then we have 7 power 1. Then we have 7 power 0 plus 7 power 1. And then what do we have? We have 7 square. Can you guys, I hope you guys are able to have a look at what's the pattern that's going on. So what will be the next term? The next term will be 7 square plus 7 power 0. The next term will be 7 square plus 7 power 1. The next term will be 7 square plus 7 power 1 plus 0. Okay guys, so this is the pattern that we have to follow. Now what's the question? The question asks us to find the position of 16856. Okay guys, so now let's get to the question. What does the question ask us? We have to find the position of 16856. So let me tell you, 16856, and we are dealing with powers of 7. So I'll try to write it in terms of powers of 7. So how will I write it? So I can write it as 807 plus 49. which is why, because I know that 7 power 5 is nothing but 16807 plus 7 square. Okay guys, so we have simplified the term that we need to find, so that's nothing but 7 power 5 plus 7 square. So now the question comes with, how will we determine the position? So I'll show you a pattern. So the pattern is, when there's a 7 power 0, it's at the first position. Then we have 7 power 1, it's at the second position. Then we have 7 square, this is at the fourth position. So let me tell you, the next term, that is 7 cube, it will come at 8th position. I can show you guys. So next term will be 7 cube. This is nothing but 8th position. I hope you guys are able to see a pattern. This is nothing but 2 to the power 0. This is nothing but 2 to the power 1. And this is nothing but 2 square. And this is nothing but 2 cube. So what does this mean? So the 7 to the power n comes at a position of 2 to the power n. So basically, we'll have 7 power 5 will be at the position of 2 to the power 5. So what is 2 to the power 5? This is nothing but 32. So now we know that the position of 7 power 5 is 32. Now what do we have to find? We need to find 7 power 5 plus 7 square. So what will the pattern in which they will come? So first we will add 7 power 0, then we will add 7 power 1. Then we will add 7 power 0 plus 7 power 1, and finally we will add 7 square. So what will be the position? So this will be 33rd, this will be 34th, this will be 35th, and finally 7 power 5 plus 7 square will be at the 36th position. So the position of 16856 will be 36. Okay guys, I hope you guys have got it. You just have to look for a pattern. Once you get the pattern, this question is quite really easy. Okay, let's move on to the next question. Alright guys, so this is a really interesting question. So what is the first thing that's been given? There's a circle, x square plus y square is equal to 36. Okay guys, so let's draw xy plane and then we'll draw the circle. Okay, so I here have my x-axis and y-axis, and then what do? I draw a simple circle, the radius of which is 6. Alright, so now what have we given? We have been given that there are two lines. Line 1 is x is equal to 4. So basically, at x is equal to 4, there will be a vertical line. Next, what has been given? We have that at y is equal to 3, we'll have a horizontal line. Okay guys, so this is what has been given in the question. And what does the question state further? So they have been divided into 4 regions. I hope just don't consider the x-axis and y-axis. Apart from x-axis and y-axis, they are basically, the circle is divided into 4 parts. So we have part 1, the biggest part over here. This will be the second biggest part, because y is equal to 3 will leave more space when compared to y is equal to 4. Okay guys, so what will this be? This area will be R1, this area will be R2, this area will be R3, and this small area over here will be R4. Okay, now what have been asked? We have been asked to determine the value of R1 minus R2 minus R3 plus R4. Now you guys might be thinking, okay, we'll have to determine the area of R4 and all. Okay, so we don't have to do any of that. I'll show you a simple trick on how you can solve it pretty fastly. Okay, so this is what is given in the question. I'll change the color and I'll show you two constructions that will simplify this question to another level. Okay. Alright, so we have taken, and now what will we do? I'll make just 2 lines. The 2 lines will be x is equal to minus 4 and y is equal to minus 3. Okay guys, so it's absolutely fine to do 2 constructions. So now what will happen is you'll be able to see that by symmetry all the 4 sections will become R4. And what will be this entire section? Okay, let me take another here. So by symmetry you'll see that this is nothing but R3. Okay guys, and now what do we have here? Okay, let me take another pen. Okay, and what do we have over here? This is nothing but R2. Okay guys, and now what will I do? What I am doing is I'll reduce a little bit of more portion. So what I'll do is I'll not take this portion, and what will the remaining portion be? So the remaining portion will be R2 minus R4. Okay guys, I hope there is no issue still here. So we have the area of this portion to be R2 minus R4, and let me change it back to green, and the entire green portion is nothing but R3. This is R2 minus R4, and this entire thing is R1. So what are we looking at now? Now I'll just look at the rectangle that has been formed. So I hope you guys are able to see that the dimensions of this rectangle will be, this is nothing but 4 and minus 4. So there's a 8, and okay, let me write it down over here. So the dimensions will be, this is the dimension of the rectangle. I'll draw the rectangle over here. So the dimensions of the rectangle will be 8 and 6. Okay guys, I hope you are able to understand why this is. This is because the two lines that are cutting are x is equal to 4 and x is equal to minus 4. That's why there is an 8, and y is equal to 3 and y is equal to minus 3 form a 6. Okay guys, so this is the rectangle that is in the center. Alright, so now what will be the area of that rectangle be? So let me tell you, the area of this rectangle, okay, will be nothing but R1 minus R3 minus R2 minus R4. Okay guys, I hope you guys are understanding what I have done. I have taken the entire R1, I have subtracted R3, and I have subtracted R2 minus R4. So what am I left with? I will be left with just the rectangle in the center. And now the moment you open that minus sign, you'll see a really interesting thing. So what will it become? We will have R1 minus R3 minus R2 plus R4. I hope you guys have seen what is this. This is nothing but what has been asked of us. So what is this area? This is just the area of rectangle, that is equal to 48. So just by doing two simple construction, this question is really easy. I hope you guys have understood what I have done over here. If you have some doubts, just try to have a look at the video again. Okay, let's move on to the next question. So here's the next question. So over here we are dealing with a base minus 2. So whenever we are dealing with a base minus 2, it's always good to write what the values will be. So first of all, we have minus 2 to the power 0, that is 1. Next we have minus 2 to the power 1, that is minus 2. This will go on. So over here we have been asked to write 2019 in terms of minus 2 into the base of minus 2. So what will we write? Let's take some values till 2019. When we see that, okay, I'll be able to get 2019. Alright. So what will be next? Next one will be next one will be 4. Then we'll have a minus 8. Then we will have a 16. Then we'll have a minus 32. Then we will have 64. Then we will have 128 with a minus sign. 256. Then we will have a minus 512. And we will also have a 1024 and minus 2048. Okay guys, so now have a look. So when I take, even if I take all these terms, when I add them up, I am able to see that minus 2048 plus 1024 will give me a negative term. But what do I have to find? I have to find 2019. So I am seeing that even if I take 1 in each and every one of these terms, I won't be able to get 2019. So what do? I take one more term. What will be my next term? The next term will be 4096. Now have a look. Now you can see that there's 4096 and minus 2048. The moment I take both those terms, what will happen is I'll get 4096 minus 2048 will be equal to 2048. So I have got 2048, which is a little bit greater than 2019. So now what do I have to do? I need to subtract some value from this. What is the value I have to subtract? I need to subtract 29 from this to get 2019. So what will be my next task? So my next task will be creating minus 29 from the terms available over here. So let me see. So 64. Okay, 64 is way too bigger. So let's move smaller. So what do we have? We have a minus 32. Okay, minus 32 looks good. But what's the problem? We need minus 29. So we'll need to change it a little bit. So what can I do? Okay, let me add 4 in it. So the moment I add 4, what does it become? It becomes minus 28. So we need another negative sign. So how do we get it? We get it by adding 1 and minus 2. So what do we have here? Let me write down the terms that I have selected. So I have selected 1, I have selected minus 2, I have selected 4, I have selected minus 32, and I have selected the last 2 terms. Okay. Now I hope you guys are able to see that by selecting just 1, 2, 3, 4, 5 and 6 terms, I am able to write 2019. And what have been asked? We have been asked how many non-zero digits does this contain. So I can write this in terms of minus to the base of minus 2. So what will it look like? It will look something like this. 1, 1, 0, 0, 0, 0. Okay, 1, 2, 3, 4, 5. 0, 1, 0, 0, 1, 1. So this is the expression of 201. This is 2019 expressed in base minus 2. So how many non-zero digits are there? 1, 2, 3, 4, 5. Okay, I think, and 6. Okay, so this is 2019 expressed to the base minus 2. So how many non-zero terms do we have? 1, 2, 3, 4, 5 and 6. So that's why we have 6 non-zero digits in 2019 expressed in base minus 2. Therefore, our answer will be 6. I hope you guys have got it. All we have to do is write all the terms of to the base minus 2. What will we get over here? And we just need to combine a few of them to create 2019. So we did it. We got the representation and the non-zero digits are 6. That's why the answer for this question is 6. Okay guys, let's move on to the next question. Alright, so let's have a look at the next question. So what is it? The n denote the number of all natural numbers n such that n is divisible by a prime and that prime p should be greater than under root of n and the prime p should be less than 20. So what do we have? The first hint we have is that it's a prime number less than 20. So what can we do? So first thing we can do is we can write down all the prime numbers less than 20. So what are the prime numbers less than 20? We have 2, we have 3, we have 5, we have 7, we have 11, 13, 17 and 19. Okay guys, so how many prime numbers do we have? We have 8 prime numbers less than 20. Alright, so what does the next condition state? The next condition state that the natural number should be divisible by this prime number and the square root should be smaller than the prime number p. So what numbers are divisible by 2? So first of all, we have 2. What is the square root of 2? The square root of 2 is less than 2. That's why it satisfies the equation. Next, what do we have? But any term greater than 2, that is 4. So what is the square root of 4? The square root of 4 is 2. So it is not less than our p. The square root of 2, 4 is not less than the prime number p. So that's why we cannot take 4. Similarly, in case of 3, what do we have? We just have 3. And what's the next term? It will be 6. So let's have a look at 6. So the square root of 6 is also smaller than p. So these two of them follow. What's the next term that is divisible by 3? That is 9. But what happens? Under root of 9 is 3, which is not less than p. So 9 does not come over here. So I hope you guys are able to see what is going on over here. So all the terms that are divisible by this prime number till it reaches the square of the prime number. So how many terms do we have over here? We have a single term. How many terms do we have over here? We have 2 terms. In 5, which will be the terms we have in 5? So we'll have 5, we'll have 10, we'll have 15 and we'll have 20. we won't have 25. So how many terms? We have 5, 10, 15 and 20. This is nothing but 4 terms. I hope you guys are getting the pattern. The number of terms available will be 1 less than the prime number. So for 7, we will have 6. For 11, we will have 10. For 13, we'll have 12. For 17, we'll have 16. And finally for 19, we will have a total of 18 terms. So when you add all these up, you will get the answer as 69. Okay guys, so the answer for this question was the total number of all natural numbers. So how many numbers do we have? We have 69 numbers. And another thing, I'll assure you that no number will be repeated because we won't any number, these are prime numbers. So the product of these prime numbers multiplied with 2, 3, 5 or 7, any number smaller than that is already neglected from here. So that's why there won't be any repetitions. You guys can write these all down and you can check, but there will not be any repetitions. So we can directly add these terms and we get the answer as 69. Okay guys. Alright guys, let's move on to the next question. Okay, now what do we have here? We have the 17th question over here. What does it state? It states that A, B, C are distinct positive integers. They are distinct such that B plus C minus A, C plus A minus B and A plus B minus C are all perfect squares. And what do we have to find? We have to find the largest possible value of A plus B plus C, which is smaller than 100. Alright, let's write down the conditions that are there. So what's the first condition? First condition states B plus C minus A is a square. Let's take it to be m square. This will be an integer because A, B and C are given as integers. Okay guys, so what's the next term? Next term will be C plus A minus B, which we can take as n square. And what's the final term? The final term is A plus B minus C, which we can take as P square. Okay guys, so now we have 3 conditions. So I'm able to see that there's a minus A, minus B and minus C. So what do I think? I'd love to add these up. So 6 of the terms will get cancelled. So what will I be left with? I'll be left with A plus B plus C is equal to m square plus n square plus p square. Okay guys, so what does the question reduce to? The question reduces to finding the largest value of m square plus n square plus p square smaller than 100. Okay, so now I'm sure that m, n and p are positive integers. So what will we know? We'll know that none of them will cross 100. So what are the possibilities? So the possibilities will reduce down to 81, 64, 49, 36, 25, 16, 9, 4 and 1. Alright, so we have 9 squares that can fit the value of m square plus n square plus p square. Anything other than 81, more than 81 will make the value of a plus b plus c exceed 100, which we cannot allow because we have a condition which states that smaller than 100. Okay guys, so now what do we know? Okay, so we have to take pairs of 3s. But can we take any random pairs of 3? No, there's another condition that will be involved over here. What will that be? That will be when you try and add any. Okay, let's add the first and the third term. So what do I get? I get 2b is equal to m square plus n square. Okay guys, and similarly I'll get a value that 2c is equal to m square plus p square, and 2c will be equal to m square plus n square, and 2a will be equal to n square plus p square. Okay guys, so I have 3 more conditions. What does this mean? Since I have a 2b over here, so this term should be an even number. So if m square plus p square is even, what does that mean? That means either m square and p square should both be odd or they should both be even. Similarly, for 2c, m square and n square should both either be odd or even. Similarly, n square and p square should either be odd or even? So what do we know? We know that all three of them. So m square, n square and p square should be odd or even. All of them should be either odd or even. So what does this do? This reduces our number of possibilities even lower. So what do we have? So let's take, we need to find the highest value of a plus b plus c. So where does my mind go? I need to take 81. Okay, let me take 81. So what does that make? 81 makes sure that I can't take any value greater than 9. So if I take 16, what do I get? I get, okay, 16, I cannot take 16 because m square, n square and p square need to be either odd or even. So the smallest possible, the highest possible value I can take is 9, and then I have 1. So what's the one value I am getting? The pair can be 81, 9 and 1. This is one possibility of m square, n square and p square. Okay guys, so what will be the next possibility? Alright, let's take the next biggest one. I'll write it with another color. Let's take the next possibility. We have 64. So we have 64. Now what do we have to do? We need to take only even terms. So what's the next even term? There's 36. But what is 64 plus 36? That is 100. So we cannot take 36. So what's the next term we have? We have 16. So I can take 16 and I can take the next even term, that is 4. Alright. So now you guys see any term. Okay, next I can take 49, 25 and 9. But you see, okay, let's take that as well. I'll write it with a different color. Okay, let's take 49, 25 and 9. So now what do we have to do? We have these three. Anything lower than this, I'm directly able to see that the sum will be smaller compared to these three. So what do we have? We have three sums. So the sum of m square plus n square plus p square over here will be 91. Over here it will be 84. And finally over here it will be 83. So what are we asked? We have been asked to find the largest possible value of a plus b plus c, which we proved was equal to m square plus n square plus p. So what do we have to do? We have to find the maximum value of m square plus n square plus p square, which is nothing but 91. Okay guys, I hope you guys have got it. We have done nothing here. We have just written the three equations that were given to us. We tried to get some deductions using those. What was the first deduction we got? The first deduction we got, what? A plus b plus c is equal to m square plus n square plus p square. What was the second deduction we got? The second deduction we got was 2b should be equal to m square plus p square, 2c should be equal to m square plus n square, and 2a should be equal to n square plus p square. So what did that give us? That told us that m square, n square and p square should either be odd or even. And finally, using all these conditions, we got three values. So we'll be able to get even more values. But why did we stop? We stopped because the question asked us to find the largest possible value. That's why the answer is 81, 9 and 1, and the sum will be equal to 91. Okay guys, I hope you guys have understood it, and let's move on to the next question. Alright guys, so this is the next question. So what does this state? What is the smallest prime number p such that p cube plus 4p square plus 4p has exactly 30 positive divisors? So before we move on, let me tell you how we find the number of positive divisors for any term. So let me take any random term. It's a power m plus b power n multiplied by b power n multiplied by c power p. Okay guys, so over here a, b and c are prime. So what is this? This is any particular number n, which I can write in this form. So the number of positive divisors for n divisors is got by multiplying m plus 1 into n plus 1 into p plus 1. Okay guys, so where a, b, c are prime and the number n can be written as a power m into b power n into c power p, the number of divisors is given by m plus 1 into n plus 1 into p plus 1. Okay guys, so now that we have got this idea clear, let's move on to the question. So what's the question? The question has p cube plus 4p square plus 4p. So what am I? I am able to see that there's a p common. And let me tell you, the moment I take p common, what is left? What's left is p square plus 4p plus 4. This is what? This is nothing but p plus 2 the whole square. So what does my term gets reduced to? It gets reduced to p into p plus 2 the whole square. Okay guys, and there's another thing given. What's given? It's given that p is a prime number. So how will I get? Now what is the question? The question deals with 30 positive divisors for this number p cube plus 4p square plus 4p. Okay guys, so what's the next step we do? So we are able to see that this is kind of in this form. At least for the first term I can say that there is a p to the power 1. So that's why we have a 2 over here. So 2 multiplied by something should be equal to, what's the number of positive divisors? So the number of positive divisors is 13. So that's why this term over here should be 15. So how many possibility ways can I split 15? I can write either 1 into 15 or 3 into 5. Okay guys, so these are two possibilities in which I can write it. So what does this mean? This means that p plus 2 the whole square should either be of the form, let me take z to the power 14. Okay, so the first possibility is p plus 2 the whole square can be of the form z to the power 14. What's the other possibility? The other possibility is p plus 2 the whole square can be of the form z to the power 2 into y to the power 4. So why did I take this? This I took because there's a 3 into 5. So how will I get 3 into 5? When I take 2 and 4, which will give me 2 plus 1 multiplied by 4 plus 1. So basically we have reduced our question to p plus 2 the whole square in the form of z power 14 or p plus 2 the whole square in the form of z square y to the power 4. I can write p plus 2 should be of the form z into y square. Okay guys, where z and y are prime numbers. So now I'll tell you guys, so over here there's no accurate way to solve it perfectly to get the value of p. So what we have next is we'll just try on substituting various values of prime numbers that is from 2, and we'll move on until we get a certain prime number p which when added to 2 comes to be of the form z into y square. So when do we get it? It's okay, I am able to understand that this is a little bit of hit and trial method, but we have simplified our question really to an extreme point where you have to check nothing but just that p plus 2 should be of the form z into y square. So how will we, when we move on checking for different prime numbers, we reach at 43. So what happens at 43? At p is equal to 43, what we get is 45 is equal to z into y square. This is nothing but 5 into 3 square. So that's why 43 is the smallest prime number for which the given p cube plus 4p square plus 4p has exactly 30 divisors. Okay guys, so the last step was a little bit of hit and trial, but we reduced the question to this form where p plus 2 should be of the form z into y square, and then we substituted various values of prime numbers. Okay guys, I hope you guys have got it, and now let's move on to the next question. Alright guys, so next question, this is the question number 19. So what does it state? It states that 15 and 9 are the lengths of two medians of a triangle, and what do we have to find? We have to find the maximum possible area of that triangle. So let's draw a triangle. Alright, so we have a triangle over here, and it's given that the lengths of two of the medians are 15 and 9. So what do we know? We know that at the point the three medians meet, the median is divided into the ratio 2:1. So what does that mean? So that means the two medians will be divided in 10 and 5, and we'll get a 6 and 3. So why is this? Because the median is divided into the ratio 2:1. Alright guys, okay, so now we have 6, 3, 10 and 5. So now how will we determine the area? So this is where a really helpful trick comes in. So there's a property in triangles wherein if you draw three medians, okay guys, so these are three medians in a triangle. Okay, let me name them. So this is a triangle ABC with the center O. If there are three medians in this triangle, the triangle is divided into three equal areas. So area BOC will, okay, let me write it over here. Area BOC will be equal to area AOC, which will be equal to area AOB. Okay guys, so what does this do? This reduces our question to we just need to maximize the area of one of the smaller triangles. So over here the other triangle will be these two. Okay guys, so other triangle will be over here and over here, not the lines that I have previously drawn. So what do we have to do? So our question becomes we need to maximize the area of this triangle. How do we do it? So let's take a theta over here. Okay guys, it can be any theta. Now what do we know? We know the area of triangle using trigonometry. What does that give? That gives area triangle is equal to half AB into sine theta. Where what? Where sine theta is the angle between the two arms we have considered for taking A and B. So over here we have taken 6 and we have taken 10 and the angle between them as theta. So what do we get? We get the area as half into 6 into 10 into sine theta. This is nothing but 30 sine theta. And now we need to maximize this area. What's the simplest method to maximize it? Take sine theta is equal to 1. So what does the area become? So we get area is equal to 30. So now what is this? The maximum area of one part is 30. So the other part will also be 30 and this part will also be 30. So what's the total area of this triangle? So the total area of this triangle will be 3 times 30, that is equal to 90. So that's the solution for question number 19. It was really simple. All you had to do was use a simple property and the formula of area of triangle using trigonometry. Alright guys. Okay, let's end this question and let's move on to the next one. Okay, so what does the next question state? So how many 4-digit numbers A, B, C, D are there such that A is less than B, is less than C, is less than D, and A minus B is less than C minus B, and it is less than D minus C. Okay guys, so similarly we need to use the conditions. So using A, B, C, D, I think the condition given second looks even better. So let's play with that. So what do we have? We have B minus A is less than C minus B. I'll take B over here and I'll move C over that side. So what does this give? This gives me 2B should be less than A plus C. Okay guys, there's another condition, that is C minus B is less than D minus C. What does this give? This gives me 2C should be less than B plus D. Okay, so we now have two different conditions and there's a third condition over here. Alright, and what else is given? It's given, so since there's no equality sign, we can say that A, B, C and D will all be different. Okay, so now so for this one the easiest method is just go on with the few values. Okay, so since A is the smallest, let's begin with 1. Okay, I can take A1. So what does that mean? That means I can't take B as 1, I'll have to take it as 2. Okay, now here comes the first condition. What's the first condition telling you? That 2B should be less than A plus C. So what is the value of 2B over here? 2B is equal to 4. Okay guys, so A plus C should be greater than 4. So what does that mean? That means I cannot take 3 over here. Okay, so taking 3 over there will be wrong because 1 plus 3 will give me 4. Which won't be less than 2B. So that's why I'll have to move with 4. Okay, now over here I can take 5. but there's another condition. What's the condition say? The condition says 2c should be less than b plus d. So what's the value again? The 2c is equal to 8, and what do we have? We have b as 2 plus d. So what does this mean? This means d has to be greater than 6. So what's there? So we have 7. So let's have a look. Now we can take the other three conditions directly. Why? Because we know the first three terms are following the rule which states that 2b should be less than a plus c. Okay guys, we have taken 4. So 4 plus 1 is 5. It is greater than 2b. So that's the condition that's satisfied. And the second condition just says that for a particular value of c as 4, d should be greater than 6. So we have got three values. Okay, so this is our first set of solution. So now let's check on what can we do. So let's try to increase c a little bit. So what can I write? I can write 1, 2, 5. So have a look. So the first condition is not broken because I am increasing c. There won't be a change in the first condition. So the first condition, there won't be any issues. Where will the issues begin? The issues will begin with the second condition. Why? Because 2c has increased, which means 2c has increased. What does that mean? That means this condition is not valid, and we'll have to write a new condition that states 10 should be less than 2 plus d. So this means d has to be greater than 8. So there's only one possibility, which is d is equal to 9. And now have a look guys. So the moment I will take a 6 over here, what will the 2c become? 2c will become 12. 12 should be less than d plus 2. So d will have to be greater than 10, which is not possible. So that's why for this set we can say that 6 won't be a possibility, and any number greater than 6 will also not be a possibility. Okay, so for 1, 2 we have checked all the values. So next step, what do? We take 1 and 3. So again you start with the first condition. What does the first condition say? 2b is less than a plus c. Again, what's the value of 2b? 2b is 6, should be less than 1 plus c, which means c has to be greater than 5. Let's begin with the simplest term, that is 6. Okay, now comes the second condition. The second condition states that 2c should be less than b plus d. What is 2c over here? 2c is 12, and 12 should be less than b plus d. So what is the maximum value of d? The maximum value of d is 9. So what is 9 plus 3? It is 12. So it will never be possible that 1 and 3 will yield any solution. We can directly remove this solution. Similarly, okay, I think I have rubbed something off. Okay, we have used this. Right, I'll write the second condition over here. 2c should be less than b plus d. Okay guys, so we have checked for 1, 2. We checked for 1, 3. We got nothing. So let's check for 1, 4. So what happens in 1, 4? The moment I put this in condition, so what do I get? C plus 1, because a is 1, which means c has to be greater than 7. So what's the first value I can take? I can take 8, but you can see again 2c will go to 16 and it will be impossible to attain this value. So that is why for any value other than these 4 values of a, we won't get any solution. So we have exhausted all the values for a is equal to 1. So what do? We move on to the next a. What can a be next? We can take a is equal to 2. Okay guys, so again let me just write a, b, c, d down over here. I'll make a border, and we have begun with a is equal to 2. So if a is equal to 2, what should be the value of b? The minimum value b can take is 3. Okay guys, so again, okay, let me rub the solution for this particular example. Okay guys, so again, what do we have? We have 2 and 3. So what do we get? We get 6 should be less than 2 plus b, which means b has to be greater than 4. So what's the first value we can take? We can take 5. Okay, and now we check the second condition. So second condition states 2c should be less than b plus d. What do we get? We get 10 should be less than, which gives us 10 should be less than 3 plus d. Okay guys, so what does this give? This gives us d should be greater than 7. So d can be 8 and again d can be 9 because rest of the conditions are followed properly. So we won't have any issues with doing that. Okay, so now have a look. So the next value of c I can take will be 6. So the moment I take 6, what will happen? 12 has to be smaller than 3 plus d. This is the same issue we faced in the first conditions, first cases. So that's why there's no possible. So any value of c greater than 5 won't yield any results. So what do we do next? We start changing b. So what can we take? We can take 2 and 4. Okay. So the moment we take 4 over here, what will change? So the first condition will change. Okay. 2b less than. Okay. All right, it's a1 1. Okay, so what do we have? The first condition. The first condition states 2b should be less than a plus c. So now what do we have? We have b as 4. So 8 should be less than 2 plus c. So c has to be greater than 6. So we can take c as c has to be greater than. Alright guys, so what do we get? We get c has to be greater than 6. So greater than 6 meaning the first term we have is 7. So have a look, there will be a problem. 2 times 7 is 14 and there is no way a b plus d will give you 7. So that's why there is no possible answers. Similarly, for any value of b greater than 4, we will not get any answers. Okay guys, so now what do? We have checked for 3, for a is equal to 2, all values. So what's the next thing to do? We'll move on to a is equal to 3. Okay guys, so now when a is equal to 3, what's the first value of b we take? Again, it's 4. So going from the first condition, what do we have here? Okay, so 4 should be greater than 3 plus c, which means c should be greater than 5. Okay, so what can we take? We can take c as 6. So what is 2c? Again 2c will be 12, but over here, since we have changed value of b, what do we get? We get 4 plus d. So what does that give us? D should be greater than 8. So what does that give us? That gives us one single value, 9. So now have a look guys. The moment I increase c, I will get 14, which will never be true. Then the moment, so we'll have to change b. So when I increase b to 5, what will I get over here? Over here it will go to 10 and we will have to take a c as 7. So when c is 7, we have seen that we won't get any solution. So similarly, you guys can check that any value, even for any value of a greater than 3, there will be no solutions which will be satisfying all the conditions that have been asked for us. So that's why the solution will only be these 1, 2, 3, 4, 5, 6 and 7 sets of 4-digit number ABCD. So that's why the answer for this question will be 7. Okay guys, so we have 7 different 4-digit numbers ABCD. Okay, I'll tell you, and take any value of a greater than 4, you'll be seeing that 4, 5, so it has to be greater than 6. So c will have to be greater than 6. So any value of c greater than 6 won't give you a d. So that's why our solutions will end at this point and we'll just have 7 correct 4-digit numbers. Okay guys, so this is the answer for question 20.